Do astronauts dream in space? Absolutely. But getting to that dream state is a challenge unlike anything on Earth. Sleeping in space isn't just closing your eyes. You have to actively prepare your body and mind for rest in an environment that resists sleep. On Earth, gravity grounds you. In orbit, you float. There's no up or down, no mattress or pillow, no blanket to signal bedtime. Astronauts sleep in small pods about the size of a phone booth inside the International Space Station. They strap their sleeping bags to the wall or ceiling to avoid drifting and bumping into equipment. That slight pressure from the straps is a faint reminder of being held in place, a small comfort in zero gravity. The act of sleep becomes a managed procedure, not just a nightly routine. They're not just going to bed, they're engineering an environment where rest is possible. The real question isn't just do they dream, but how do they even fall asleep? It's a testament to human adaptability. Even in the void, they find ways to rest and let their minds wander. For a few hours they make the most alien environment feel just a bit like home. And yes, they still dream floating in the dark far from Earth. Sleeping in space brings physical challenges like fluid shifting upward, making your head feel stuffy and your face puffy. It's like having a mild, constant head cold every night. Your legs thin out your taste and smell dull, and it's hard to relax. The ISS is never quiet. Fans, pumps, and electronics hum around the clock. Earplugs help, but it's another adaptation just to get some rest. Many astronauts use sleeping pills to cope. It's not ideal, but when safety and performance are on the line, quality sleep is essential. The goal? Make sure every crew member is rested enough to handle complex tasks. Sleep aids bridge the gap between what their bodies expect and the reality of space. In the end, sleep in orbit is a constant negotiation with discomfort and noise, but they find ways to make it work. One of the biggest obstacles to sleep in space is the disruption of our circadian rhythm. On Earth, sunrise and sunset guide our body clocks. On the ISS, astronauts orbit Earth every 90 minutes, 16 sunrises and sunsets a day. Their bodies lose their natural cues and internal clocks drift. To compensate, astronauts follow a strict schedule and use artificial lighting to mimic a 24-hour day. Lights are bright during daytime, dimmed at night. Still, astronauts often feel a persistent jet lag. Fatigue, mood changes, and reduced focus are common. Sleep is not a luxury, it's critical for safety and mission success. They actively manage their schedules and light exposure to keep minds sharp. In space, even sleep requires discipline and planning. The stakes are too high for anything less. Despite all the challenges, astronauts do dream in space, and those dreams can be even more vivid than on Earth. Many report dreams of floating, spacewalking, or gazing down at Earth. The mind seems to adapt, practicing weightlessness even in sleep. Just as often, we dream of home, wind, rain, family, and familiar comforts. These dreams are emotional anchors connecting us to Earth. Some research suggests astronauts get more REM sleep in orbit, possibly to help process the flood of new experiences. The brain works over time, adapting to the strangeness of space. Dreams become a bridge between two worlds, the adventure above and the life left behind. Even in zero gravity, minds find ways to cope, learn, and remember. Dreaming, it turns out, is as universal as gravity itself. Sleep quality directly impacts astronaut health, safety, and performance. In space, alertness is a matter of survival. Fatigue can lead to mistakes, slower reactions, and impaired judgment, risks no mission can afford. That's why space agencies invest in sleep research, lighting systems, and new sleeping quarters. Astronauts monitor their sleep test solutions and adapt strategies for long missions. Sleeping and dreaming in space reveal their capacity to adapt, even in the most hostile environments. No matter how far we travel, our brains need rest and dreams to function. As we plan for Mars and beyond, mastering sleep will be more critical than ever. The lessons learned on the ISS pave the way for future explorers. Rested minds are ready minds, essential for humanity's next giant leap.